as I said in the video lecture of chapter 13, in this chapter we're going to talk about kinetics of particle, and kinetics is always related to the forces. However, using Newton's second law, I know that the forces, the sum of forces is related to acceleration. So I may use the kinematics equation of chapter 12 in order to find the acceleration if it is unknown, so that I can find the unknown forces. All right? I'm going to start by the first problem. And this is a simplified problem, a very simple problem where I have a 50 kilograms crate starting from rest. Starting from rest means V0 is equal to 0, and achieving a velocity of V is equal to 4 meters per second when it travels a distance of 5 meters to the right. So after a delta S is equal to 5 meters, the velocity will be equal to 4 meters per second. I need to determine the magnitude of the force P acting on the crate to push this crate to move to the right. And guys, what you have to know here that this P is constant, and the angle done with x-axis is always constant, right, all over the path, okay? Because I'm gonna use this statement in order to prove that A is also constant. I have the coefficient of kinetic friction between the crate and the ground is equal to 0.3. Whenever they give me, guys, the coefficient, this means that there is a friction force. If they didn't give me any coefficient or any data about the kinetic friction, then this means that there is no friction or the friction is neglected. All right? So as I said, guys, in the procedure to solve such problems, the first step is to draw or is to indicate the reference. Now here, since this is a rectilinear motion, so I'm going to indicate the rectangular components x and y. Right? So assume that this is the positive x and this is the positive y. And then the second part is to draw the free body diagram. Right? So I'm going to assume that this is like a particle, or I can assume that all the forces are acting on the center of gravity. Okay, on the center of gravity of this crate. So what are the forces acting on this crate? Of course, I have the weight, I have the normal force, I have this P that is doing an angle of 30. So guys, I transported this force from here to the center of gravity, all right? And of course, I have the normal the friction force that is related to the normal force. It's always related to the normal force using this equation, UK times N. So this is the friction force, right? I'm gonna call it F. Okay, guys? So now since this is a 2D case, I'm gonna apply the sum of forces in vector form that is equal to MA, which is Newton's second law in vector form. I'm going to convert it to scalar form in X and Y because this is a 2D case, right? I'm gonna convert it to form. Sum of X is equal to MAX and sum of Fy is equal to MAY. Now, which one of these two components, AX or AY, is equal to 0 and Y? So which one, AX or AY, is equal to 0 and Y, guys? What do you think? Quickly, please. AY is equal to 0 because there is no motion in Y direction. So there is no even V in Y direction, all right? So the only motion is in X axis or along X axis. So that's why AY is equal to 0, okay? So I have two equations, 1 and 2. I'm going to start by sum of X is equal to 0. So what this will give me? Okay, so sum of Fx is equal to 0. This will give me what? What are the forces? What are the projection of forces in X direction? I have, of course, P cosine 30, and I have minus the normal force, which is F, minus the friction force, which is FF, and this should be equal to MA. I'm gonna call it MA, guys, because in fact A is equal to AX since I don't have any AY, and then sum of FY is to 0, and this will give me N minus the weight plus P sine 30 is equal to 0. What do you think, guys? How many unknowns do I have here? What are the unknowns in these two equations? So my unknowns that I'm gonna put them in orange are P, this is the question, it is to find this P, N, all right, and A. No, I know A. So I know A, guys. No, I don't know A, right? And A. So I have three unknowns because in fact FF is related to N. It is mu K times N. So if I know N, I can find FF. So I have three unknowns here. Three unknowns. What are these unknowns? They are P, N, and A. So how many equations, guys, do I need to solve for these unknowns? How many equations? Since I have three unknowns, this means that I need three equations. What do you think is the third equation? What do you think, guys, is the third equation? What should be the third equation? Yes, from kinematics. So from the equations of kinematics, I can find the acceleration A and plug A in these two equations so that I can find the equations, the unknowns, right? So how to find this? FF is the friction force. It is mu K times N. This is FF job. Okay. Now, how can I find this acceleration? In fact, guys, if I go back to this equation, P is constant, and this will also imply that N will be constant, right? So let's guys start from this equation right here, all right? From this equation, P is constant, so I'm always pulling this crate with the same force using the same angle. So same force, same magnitude, and same means same direction, all right? So I have the same force, same direction, which means P sine 30 is constant, all right? And W is constant, this means that N is constant. And then if I plug this N is constant in the first equation, N is constant means the friction force is constant. P is always constant, then this means that A is constant. All right? So, since all the forces are constant, then this means that A is constant. And since A is constant, guys, what does this mean? Then this means that this is a uniformly accelerated motion. So I can apply the equations of kinematics for this type of motion, right? What do you think is the best equation? So what should be the best equation? Let's go back to the problem. I have V0, I have V at a certain S or X, all right? So S here is X because the motion is along X-axis. So let's write down, guys, my data. So the data are, I have V0 is equal to 0. And I have that V is equal to 4 meters per second. And I have S or delta S or X minus X0 as 5 meters. So what do you think, guys, is the best equation to use? It is V squared 2 is equal to V0 squared plus 2AS, which means it is the independent equation of time, right? So this is the equation that I should use, right? So remember, V squared minus V0 squared is equal to 2a x minus x0. All right, guys? Now, since this is 5, and since this acceleration should be known, and since this v is 4, which means 16 minus 0 is equal to 2a times 5, then a will be equal to what? It will be equal to 1.6 meters per second squared. Now that I know a, if I go back to the equation, sum of x, sum of fy, I know a, I can find these two equations because I'm going to have only two unknowns. I can now, so I know a, solve two equations, two unknowns, to find P, and you can find, I know the value, it's 224. All right, so guys, in this problem, I have to use the equations of motion in x and y, as well as the kinematics equation, especially here in uniformly accelerated motion. Any question, guys? Quickly, please.